When you see a stock price pop up on your screen, what are you really looking at? We're about to pull back the curtain on the numbers that run the entire global economy. And trust me, it's a world that is way more complex and surprisingly fragile than you could ever imagine. It always starts with something so simple, something we all instantly recognize. Just four letters. A-L-P-L. Apple. It feels solid, right? Instantaneous. Real.
But what is actually powering that simple symbol? I mean, what kind of massive global machinery is whirring away behind the scenes just to deliver that one little piece of information to your screen? Well, that's the journey we're going on today.
So the first thing you have to realize is that the ticker symbol we all know and love, it's really just the friendly public-facing nickname. It is just the tip of a massive identification iceberg. And what's just fascinating, right, is how much psychology is packed into these little codes. I mean, there's actual research showing that stocks with clever tickers, like Pizzo for Papa John's or LUV for Southwest Airlines, can actually outperform the market. It's a perfect, kind of weird example of behavioral finance in action. But okay, for global trading, the system needs something way more rigorous than just a catchy name. And this is where standardized codes come in. In North America, you've got something called a SUSIP. But the real global standard, the one that works everywhere, is the ISIN, the International Securities Identification Number. It's a universal 12-digit code that leaves zero room for confusion. It basically turns a memorable name into a precise global address. All right, so we know how a security is named, but where does the data about it, its price, its trading volume, where does that stuff actually come from? Well, it's not from one single place. It's this incredibly complex and layered ecosystem. Think of it like a data food chain. At the very top, you have the primary sources, the exchanges themselves, like the New York Stock Exchange, where the trades are actually happening. Then come the big financial platforms, like a Bloomberg terminal, which package all that raw data with powerful analytics. Below them, you've got specialized data vendors. And then finally, at the bottom are the free sites that most of us use, like Yahoo Finance, which usually just give you delayed end-of-day summaries. And this whole layering thing brings us to a surprisingly tricky, almost philosophical question. When we talk about a stock's closing price for the day, what do we actually mean? Because in a 24/7 global market, the whole idea of the close is a very slippery concept. Just think about this for a second. The market in Sydney, Australia closes at 4 p.m. their time. At that exact moment, it's only 7 a.m. in Lagos, Nigeria. Their market isn't even open yet. The Nigerian exchange won't close for another 9.5 hours. So when you try to compare closing prices for that day, you're not comparing apples to apples at all. You're looking at data points that were captured worlds and hours apart. Now let's move beyond the complexities of time zones and identifiers because there's an even bigger problem. Simple, plain old human error. And when you're dealing with this much data moving this fast, mistakes aren't just possible, they're inevitable. And the consequences, well, they can be catastrophic. I want to tell you a true story from 2005 that honestly sends a chill down the spine of anyone who's ever worked in finance. It involves a global bank and what has to be one of the most expensive typos in all of history. So here's exactly what went down. A trader wanted to sell one single share of a company for 610,000 yen. But in a classic fat finger error, he accidentally swapped the price and the quantity fields. So the system sent out an order to sell 610,000 shares for just 1 yen each. The bank, as you can imagine, is scrambling to cancel the order. But the Tokyo Stock Exchange's system at that time just couldn't stop it. The trade went through. The final cost of that one tiny typo? 225 million US dollars. Poof, gone in an instant.
And you know what's so wild about this? This entire disaster could have been prevented with some basic financial common sense. I mean, a human, or even a decently programmed system, would ask really simple questions. Wait, is this price 600,000 times lower than the last trade? Are we trying to sell more shares than the company has even issued? The answer to all of these is obviously no. And a smart system would have just rejected the trade right then and there.
And look, the dangers go way beyond just typos. There are these other, more subtle traps lurking in the data. For instance, you always have to adjust historical prices for things like stock splits. But even more insidious is something called survivorship bias. If you build a trading strategy by only looking at the companies that are successful today, your results are going to look amazing. But that's because you've completely ignored the giant graveyard of all the companies that went bankrupt along the way. And this complexity, it just explodes as you move between different kinds of assets.
I mean, tracking one common stock is one thing, but for that same company, there could be dozens of different bonds. And when you get to the world of options, oh man, suddenly there are literally hundreds of choices. The data management challenge just grows exponentially with every single step.
So, that's the core of the problem, right? Financial data is vast, it's messy, and it's absolutely filled with hidden traps. So how does anyone possibly manage all of this? How can we make any sense of it at all? Well, the answer, it turns out, lies in a completely different and much newer set of tools. This is where the fields of data science and machine learning finally enter the picture, and they offer us a way to navigate this just massive ocean of information. We are living in the era of big data. And the easiest way to think about it is with the 4 Vs. The volume is like an ocean of data. The variety means it's not just numbers, but news articles, satellite images, social media posts. The velocity means it's all streaming in at lightning speed. And then there's veracity, which is the constant question, can we even trust that this data is accurate? Your average spreadsheet just can't handle this world. This is where data science really shines. Machine learning algorithms can dive into all those unstructured sources, like the sentiment of news articles. They can uncover these incredibly complex patterns that older models would have just completely missed. And this doesn't just improve forecasting, it can even help us spot the early warning signs of the next financial crisis. Okay, so this is obviously powerful stuff for traders and big banks. But why should the rest of us care? What's the connection from Wall Street to, your street? Here's the crucial point. This technology isn't just for making money. Central banks and governments use these exact same techniques to monitor the health of the entire economy. Better data and better models lead to more effective policies on the things that affect all of us: jobs, inflation, and economic growth. MIT professor Roberto Rigobon puts it perfectly. He says the goal isn't just to fix the damage from past crises, the aim is to build better for the next generation. And using data science to truly understand our economy is a huge part of that. So we're left with this final thought. Data is now the engine of our global economy. And as it grows ever more complex, the real question becomes, who will be the ones to master that complexity? Who will tame this beast? And what new world will they build with it?